So quantitative data, 2 sets is what we're looking at next. So my first example here is my mountain bike rides. So it's a little too big. So I'm going to share this. Copy it. If you want to play in this sheet too. So I'm just going to do a few different examples here. So I might have told you guys before, one of my hobbies is mountain biking and road riding. And so here's a list of a few mountain bikes I did last year. So my computer on my bike or on my phone keeps track of how many hours. And here, instead of hours and minutes, I have decimal hours. So the 0.11 isn't 11 minutes, it's 11 hundredths of an hour. So this would be 80% of an hour here, for example. So this isn't hours and minutes, it's just decimal time in hours. And then the distance I traveled. And so that 6.97 means I went almost 7 miles for that ride. If I take both of these sets of quantitative data together and I graph them as points, where like this is the X value and that's the Y value, I get what's called a scatter plot. And so feel free to either just watch what I do in this one right here, or to, if you want, make a copy of it. So I'm going to ask Google for a chart. And it may not give me a scatter plot at first. Oh, it did. And then it takes the first column, makes that your X values, and the second column is the Y. And so each point here is one of my points over there. Now, these weren't in any order here. So the shortest ride time I had was the 0.8 hours, 5 miles. So that should be this point down here. And then the longest ride I did over here is the 2, and if I click on it and then point to it, it tells me which one it is. That's the 2.134 hours, and I went 15 miles. So I'm not biking very fast because I'm off-road, there's a lot of hills. But what you should see is that the longer I spent riding, the farther I went. So the points have a slight uphill trend to them. When we see some kind of trend to a set of points like this, this is called association or correlation. So it looks to me like my time and my distance are related. And that kind of makes sense because we're used to the formula distance equals rate times time. Now, I could draw a line through this in a couple of ways. One, I could just pick 2 points, like maybe this point here and that point there, and then calculate the slope between them. You guys have done plenty of that in other math classes. I'm not going to worry about that here. I'm going to tell the computer to graph a line here. So once I have a scatter plot on the screen, to graph the line, I just go to edit the chart. And under customize, the series are the data values I have here. So I want, for the series, I scroll down there, one of the options is to draw a trend line. And so it draws a line through the points. So the computer believes that this line right here goes through the points the best, so that it's on average closest to all of the points on average. This is called a regression line. If I go back to the settings, it will even give me the equation for it. So edit chart, customize series. If I look down a little farther after that trend line option, I can label that trend line with the equation. So it says, oh, the equation, my slope is 7.09, so about 7. That would be 7 miles per hour, right? Slope is rise over run. The other thing I can add to this, which the book talks about, once you get that reading, edit, customize, series. Underneath label use equation is to show R squared. And so I'm going to put that in here too. So it says R squared is about 0.7. So R squared is what we call the coefficient of variation. What I want is R. So I'm just going to make a note down here. According to that graph, the slope on average between those points is about 7, and rise over run would mean miles per hour. The y-intercept is the point 1.35. That would like be having the point. If x is 0, y is 0.35. So if I didn't spend any time biking, I've gone 1.35 miles. So the y-intercept doesn't make sense physically, but we need it to get the line in the right spot. And then the other thing they gave me was r squared, but I just want r. They said it's about 0.7 right here, so I'm just going to take the square root. So I'm going to go equals SQRT of 0.7 to get my R value. And so it says it's about 0.83. So just a couple of notes about what these numbers up here mean. So we're looking at scatter plots and trend lines. The typical trend line is also referred to as a linear regression equation. And when we calculate the linear regression, we usually get 3 different numbers. We get the slope, we get the y-intercept, and then we either get r or r squared. R is the correlation coefficient. But sometimes these computer programs give us r squared instead, and r squared is called the coefficient of variation. And I'm only bringing up the coefficient of variation because that's what Excel and Google spit out. But our book only talks about the correlation coefficient. The correlation coefficient, R, tells us a couple of things about the points. So the number R is going to be between -1, it could be -1, and 1, it could be 1. The closer to 1 or -1 means the points line up. So if I have an R that's close to 1, what that means is the points mostly line up. And they're going uphill. So I have a positive slope. If I get a number close to -1 on the other side, that still means the points mostly line up. But I would get a negative slope. So a negative correlation coefficient just means a negative slope. Doesn't mean anything bad. So they're going downhill instead. If we're somewhere in the middle here towards 0, so if R is about 0, or even like less than in the 0.5 region, that means the points don't line up. They're very scattered. So I just want to give you a few more examples of that. So with my bike rides, I get an R of about 0.8, which means, yeah, they line up okay. Not bad, not outstanding, but they kind of line up. So on average, if Gary bikes more hours, he covers more miles, is what it's telling me there. So we're going to jump back over to stat key. So if you have that stat key tab open, come back here, and then we're going to switch by clicking the stat key button at the top. And then under descriptive statistics, 2 categorical variables. If you're not sure how to get there, I'll put that in the link here. So you can just click it. And then that's the home page to, not categorical, sorry, to quantitative variables. And they have a whole bunch of different data sets, and I know what most of them mean, but not all of them. So notice this one right here is kind of a cloud of points, but I do kind of see a downhill trend to these points here, I think. I can ask it to show the line through them, and you can see the line does head down. And again, it calculates a line that is closest to all of the points on average. How to calculate that's a whole nother story. You would look at that if you took a couple of courses in statistics. So it's a little beyond the scope of what we have time for. The data we're looking at here, Florida lakes, mercury versus pH, is each data point comes from a different lake in Florida where they caught a whole bunch of fish and they measured how much mercury was in the fish. And then they also took a bunch of measurements of the water in the lake and found the average pH. And what they're looking at is there a relationship to the pH of the water and the amount of mercury that ends up in the fish in that lake. Let's see, do they have the R value here? Yeah, so the correlation is their R value. Notice it's negative and it's around 0.5. So the 0.5 tells me is the data is kind of cloudy, it's kind of spread out. But there is a slightly perceivable downhill trend when we look at that data. It's just kind of spread out. So that's not a very high correlation. It's negative. All the negative means is it's downhill. Ignoring the negative, it's about 0.5, 0.6, which means the data is spread out. Let's look at a different one here. So if I go up to the title or the arrow, I want to look for the cricket chirps. This is a cute one. So researchers observed crickets at different temperatures. And here it has the temperature on the vertical axis and the crickets on the horizontal. And this would mean that cricket chirps allow you to predict temperature. So if you heard a cricket chirp 150 times in a minute, you would say the temperature is probably about 72 degrees Fahrenheit. If you heard a cricket chirp 182 times a minute, then you would say, it's almost 80 degrees outside. So this line here is telling us how to interpret the number of cricket chirps to predict the temperature. Now, really, this goes the other way. So I'm going to switch the variables. It's the temperature that causes the crickets to chirp slower when it's cold or faster when it's warm. And this idea that one variable causes another to change is what's called causation. The number, the correlation, just means there's a mathematical pattern going on, but that mathematical pattern could be meaningless. And I'll give you an example of some meaningless data in just a second. But in this case, there seems to be a scientific reason, right? When it's cold out, we kind of slow down a little bit, and when it's warm up, we speed up a little bit. So the crickets chirp faster and higher temperatures is what this is showing us here. And not only do we have correlation, right? Notice this correlation number is almost 1. 1 is as high as you can get. If it were 1, it's a perfectly straight line. So if I were to edit this data and do something like 0, 0, and then 1, 1, 2, 2, 2, 3, 3, I'm making points that line up perfectly. Let's do one more. Doesn't have a header row. I'm going to get a correlation of exactly 1 because my points make a perfectly straight line. There's no cloudiness to it. Let's look at a couple of others here. Margin versus approval rating. So this was presidents serving a second term. Their margin means how many points they won the election by over their opponent. And approval means their approval rating at a time. So if a president has a high approval rating, are they likely to win the election and have a margin of error that's positive? Sorry, a margin difference between the votes they got and their opponent positive. Notice 0 is right here in the middle. Okay. So a low approval rating, under 50, they are in the negative margin, which means they lost the election. If their approval rating was above 50%, then they had a positive margin, meaning they won the election. All right, let's see, I want to show you an example of nonsense correlation. So I collected some data, actually I found somebody who collected some data on the per capita consumption of chicken in the US. So in the year 2000, the average person ate about 54 pounds of chicken each year. In 2005, the average person ate around 60 pounds of chicken per year in the US. Now, I also have the average daily precipitation in Montana. And if we graph these two sets of data together, so I'm just looking at the chicken consumption and the rain in Montana, these points kind of line up. So what I have here is correlation, that as chicken consumption rises, Montana gets more rain. Now, do you think there's really a reason that eating more chicken makes it rain in Montana? That seems a little crazy. So another website that has some other crazy correlation like this. So again, I have correlation here, but I don't have causation. And those are two very important concepts, and they're distinct but related. So this is activity 7.1c, the share your work trend lines. StatKey has a bunch you can choose from, and then spurious correlation has a bunch of crazy ones. And I'll show you how to use spurious correlation if you want to go look there for some crazy stuff. So the top one says, if we compare US spending on science, space, and technology, it correlates with suicides by hanging, strangulation, and suffocation almost 100%. So if we were to graph these as the x-axis being US spending and the y-axis being suicides, we would find that these guys make a pretty straight line, which is different from what I see here. Another one here, Nicolas Cage films versus the number of people who drowned by falling into a pool. If Nicolas Cage made a lot of movies in a particular year, more people drowned in pools. If Nicolas Cage made very few movies, less people drowned in pools. And if we were to graph these two together, we would find the points kind of lined up. In order to use this to do an actual line graph, we have to, let's see, where's the link here? If you wanted to get crazy on this site, I think it's down at the bottom. He has a place to explore his data. Yeah, discover correlation. So the way his site works, if you wanted to explore it to find some interesting data, is first you have to choose a variable. And he gives these different variable categories. So maybe interesting causes of death. And then I click view variables. And it gives me a whole bunch here. So then I pick one. So let's see, how about people who slipped on the ice and died? So people who died falling out of their bed. No, that's kind of, how about fell off a ladder? People killed by misusing a non-powered hand tool. Oh, that's a crazy one. All right, I'm gonna go with people who fell off a ladder. Then after I choose the first data set, I hit correlate. And then what it does is it finds a whole bunch of other data that might go well with it, and it gives you the R value. And so US military spending, General Mills sales, visitors to Disneyland. Let's check that one out. So then I hit chart it. Once I chart it, I don't really care about this graph right here. What I want is just the data. Now there's not a lot of data points here, which makes it not as much fun, but I would just highlight this chart here, and then I can use this in Excel to make a plot. So then I should just be able to paste it in, and it kind of messed up where the year goes, but I don't really need that. I just want to graph these two rows here. And I think I should just be able to hit make a chart. And it should do a scatter plot. Yeah, so it has people who fell off a ladder versus Disneyland, and they kind of line up. So then we would just go to series, trend line, use equation, show R squared, and then it gives me the information I need about this particular line. So what this shows is that the more people who die by falling off the ladder in a particular year, the more people go to Disneyland. Crazy stuff. Is there a reason? Maybe. There could be some other variable in between that makes that, but this could be what's called a spurious, meaning false connection. So I just picked two data sets that mathematically are related, but in reality, they're really not. So this is just there for fun if you want to come up with some silly or morbid example. Otherwise, StatKey has a lot of good examples. If you see something in here you find interesting but you don't know what it means, just send me a note and I'll tell you what the variables represent. But some of them are pretty straightforward, like restaurant tip versus bill. The more people spend on their bill, the more they tip. The question then would be, what does the slope mean? Oh gosh, I'm over time. Okay, I'm gonna shut up here. Hopefully I have enough information to finish those assignments and maybe get them mostly done in class together.